The concept of time travel has captivated the human imagination for centuries, serving as the fertile ground for countless stories of adventure, caution, and existential wonder. From H.G. Wells's intrepid time traveler venturing into the distant future to modern blockbusters that play with the delicate threads of history, we are endlessly fascinated by the possibility of breaking free from the linear, relentless march of time. But is this purely the domain of fiction, or is there a sliver of scientific plausibility to be found? The answer, buried deep within the complex mathematics of modern physics, is a tantalizing and deeply complex mix of yes, in theory, perhaps, but with impossible hurdles, and absolutely not for fundamental reasons. To unravel this, we must journey through the strange landscapes of Albert Einstein's theories of relativity and confront the logical paradoxes that threaten to tear the very fabric of reality apart. The most scientifically sound form of time travel, and one that is in a sense already proven, is travel to the future. This isn't a matter of stepping into a machine and disappearing, only to reappear in a futuristic cityscape. Rather, it is a consequence of one of the most profound discoveries of the 20th century, the malleability of time itself. Before Einstein, time was considered absolute, a universal clock ticking at the same rate for everyone, everywhere. Einstein's theory of special relativity, published in 1905, shattered this notion. He posited that the speed of light in a vacuum is constant for all observers, regardless of their own motion. A bizarre and counterintuitive consequence of this is time dilation. The faster you move through space, the slower you move through time relative to a stationary observer. This isn't just a quirky mathematical trick, it's a measurable physical reality. Imagine a pair of twins. One stays on Earth while the other boards a spaceship and travels at, say, 99.9% the speed of light for a year. Upon returning, the spacefaring twin would find that decades have passed on Earth. While they have only aged 1 year, their sibling on Earth would be an old man or woman. In effect, the traveling twin has leaped into the future. This phenomenon is a constant consideration for modern technology. The clocks on GPS satellites, which orbit the Earth at high speeds, tick slightly slower than clocks on the ground. If engineers did not correct for this relativistic effect, the entire global positioning system would accumulate errors of several kilometers per day, rendering it useless. Einstein's later theory of general relativity, published in 1915,